Today we will start with the summary of the graphing, and we are dealing with graphs in kinematics. So what do we have in kinematics are three types of graphs: as a displacement time graph, is the velocity time graph, and the acceleration time graph. Those are the three graphs that we discuss in kinematics. Now, if we have a displacement, or when we are moving from the displacement time graph and we are constructing the velocity time graph, and then from there we are constructing the acceleration time graph, what we are doing is we are calculating the slope of the line or the part of the graph. And when we have or we know the information about the acceleration time graph and we are constructing the velocity time graph and then further the acceleration time graph, what we are doing is we are calculating the area under the graph. When I say this, what do you have to keep in mind is that the area that is above the x-axis is positive and the area that is below the x-axis is negative. And since we are talking about the a vector quantity, then we have to take into the consideration the positive and the negative areas of the graph. Now let's see some cases in which we are talking and discussing or seeing what is happening with the velocity time graph and displacement time graph and so on. So now, when we have a displacement time graph that is straight line going up, then what do we see in terms of the velocity time graph is a line that is parallel to the x-axis or time axis. And then for the acceleration time graph will be 0. That tells us that we are dealing with a uniform motion. And now if we have a displacement time graph that goes down, displacement time graph that goes down like this, then the velocity time graph will be negative because the slope of this line is negative, and the acceleration time graph will be 0. And again, what we are doing here, what we are dealing with is a uniform motion. Do you have any questions? And how do you calculate the slope? Is easy because the slope, the formula is even in your formula sheet. And then you always go, well, what is in the y-axis is the displacement, and what is in the x-axis is the time when we are dealing with position or displacement time graph. And when we are calculating the slope for the velocity to see the acceleration, then again, delta y over delta x, whatever is on the y-axis is the change of, or the velocity, and whatever is in the x-axis is the time. So this is when we are talking about velocity time graph. Okay. So now the problem becomes more complicated when we are seeing or looking at a displacement time graph that is either curve up or curve down. So when we have a displacement time graph that looks like, let's suppose, like this, then the velocity time graph is negative. Okay, so it is falling down. Because imagine that you are throwing water here and nothing is holding, okay? So this is falling down. And then the acceleration time graph will be a negative one. So this is telling us that we are dealing with a non-uniform motion, a motion that doesn't have the same velocity. The velocity changes because the change of the velocity will produce acceleration. And let's see a different case when we have a displacement time graph that looks, let's suppose, like this. And then the velocity time graph will be a positive. So imagine that you are pouring water here, then you are able to hold it. So the velocity time graph will be positive, which will produce, or going up, not positive, which will produce an acceleration time graph that is positive. As I have mentioned, the Physics 20 class doesn't require you to actually calculate what is the graph, what is the slope, how far does it go, and so on and so forth. But it is expected you to know that when you have a curve down or a curve up displacement time graph, then you have to draw, or you have to expect that the velocity time graph will be falling down or going up, and the acceleration will be negative or will be positive. Is it clear? So now we'll take a look if we have a velocity time graph, and I will take them step by step. So velocity time graph that is like this. And let's suppose that we have a time of 2.0 seconds, and this is plus 5 meters per second. And what we are doing is we are calculating the acceleration time graph and the displacement time graph. In order to do that, what do we have to do? As we mentioned at the beginning of the class, we have to calculate the area under the graph. So the area under the graph is, when we are using the expression of the area under the graph, what we have in mind is we are going from the horizontal axis, time axis on this case, up to the graph. So whatever is under the graph, this is the area. So what do we do when we calculate the area? We see, what is it? Is a triangle or is it a rectangle? Those are the two cases that you will see on Physics 20. So in this case is a rectangle. So the area for the rectangle will be base times height. And the base is 2, the height is positive 10. So the area will be positive 10. Did I say positive 10? 5. I went a step ahead. Sorry. So the area, that means that the displacement during this time is positive 10 meters. So then what do we do when we are constructing the displacement time graph? We will see, start by stating the axis, seconds, meters. And then we're saying at 2 seconds, the object is going positive 10 meters. Positive 10 meters is above the x-axis and will be, based on the scale, let's suppose that will be somewhere in here. Now the question is, how is the object going at that position? Going straight, curve up, or curve down? I want to see some answers here. Straight, curve up, or curve down? It's going straight. Okay, so the displacement time graph will be a straight line. So when you see a velocity time graph that is parallel to the x-axis, the displacement time graph is a straight line, either going up or going down. We will see a case when it is going down. So now on the case when we are constructing the acceleration time graph, someone on the comment said that is since the velocity is constant. The fact that the velocity is constant means that the acceleration is equal to 0. So at 2.0 seconds, the acceleration time graphs is this one here, because what do we do on this case is we calculate the slope, and the slope of the horizontal line is equal to 0. Okay, let's see a case, another case, when we have a velocity time graph that is negative. So it is a velocity time graph that goes like this. Positive or 5.0 seconds, and this is negative 8 meters per second. So now when we are calculating the area under the graph, we go from the x-axis up to the graph. So this is the area that we are talking about. The area on this case, since it is a rectangle, is base times height. And this will be 5.0 times negative 8. So the area will be negative 40 meters. That means that the displacement is negative 40 meters, whatever the negative means for that particular situation. So now let's start and build the displacement time graph. So time and displacement. We always will assume that it starts from 0 unless there is a given situation, but it's safe to assume that you're starting from 0. So this is 5.0 seconds, and during that 5.0 seconds, the object is moving 40 meters down. So based on the scale, let's suppose that the negative 40 is here. And now the question will be, how is the object going there? Straight, curve up, curve down. Those are the three options so that you will see. And straight, yes. It's going straight because the velocity is constant, is not changing. It's a straight, it's a line that is parallel to the horizontal axis. So will be a line that is straight. And we are assuming that this is straight, even though that it doesn't look that straight in the graph. And then when we are calculating or constructing the acceleration time graph, and then what we are doing is we are calculating the slope. And since the slope of a horizontal line is equal to 0, the acceleration will be 0. Questions? So now let's have a more complicated graph into velocity time graph. So now let's suppose that we are dealing with a velocity time graph in which the velocity is changing. So let's suppose for 4.0 seconds, the object is from 0, starting from rest, is going to positive 12 meters per second. And on this case, again, we will construct the displacement time graph and the acceleration time graph. And again, when we are calculating the displacement time graph, what we are doing is we are calculating the area under the graph. So from the horizontal line up to the graph. This one here. Since the geometric figure that we see here is a triangle, then area will be 1/2 base times height, or 1/2 times 4 times positive 12. So area will be positive 24. At 24 meters. That means that the displacement from 0 to 4 will be positive 24 meters. So now let's start constructing the displacement time graph. So displacement time graph, 4 seconds. Let's suppose that is somewhere in here. And at 4 seconds is going positive 24. So positive 24 based on the scale will be somewhere in here. So good. Now the question that you have to ask yourself will be, is the object going to this positive 24 as a straight up, curve up, or curve down? And the answers here are that will go curve up. Why is it curve up? Because the velocity time graph is going up. So curve up because the velocity is going up. Good. And now, in order to calculate or to construct the acceleration time graph, what we have to do is we have to calculate the slope of the graph. So now the slope, like any slope, is delta y over delta x. Our y is the velocity, and our x is time. So the slope will be positive 12 over 4, which means that is positive 3, and the units are meters per second squared. So now the acceleration time graph for 0 to 4 seconds will be, based on our scale, 3 is here, will be something like this. Questions? So now we'll see a case in which we have the velocity time graph as it is falling down into positive and into negative. So we'll see something like this. This is the velocity time graph, and it is starting at positive 8. It is going down until 3 seconds, and then it's going further down into up to, let's say, 5 seconds to -7. So in this case, again, we will construct the displacement time graph and the acceleration time graph. When we are constructing the displacement time graph, what we are doing is we are calculating the area. And when we are constructing the acceleration time graph, what we are doing is we are calculating the slope of the graph. So for the area, we have 2 parts here. One of that is area under the graph. That is positive, so the positive area, this one here, which you can call it A1, A, B, C, whatever you want. I'm okay with anything. And this one here, that is area 2. So let's start and calculate the areas of those 2 graphs. So area 1 will be, is a triangle, 1/2 base times height, or 1/2 times 3 times positive 8. So area 1 will be positive 12 meters. So for the first part of the motion, for the part that is from 0 to 3 seconds, what do you have? The object is moving in the positive direction 12 meters. Okay? And then area 2 is again a triangle. So the formula will be 1/2 base times height. And will be 1/2 base is this one here. So it's 2 seconds. Times height is this one here. So it is -7. So area 2 will be -7 meters. And since we are here, let's calculate the slope. So the slope will be delta y over delta x. Our delta y is v over time, that is our delta x. For the first part of it will be 0 minus positive 8/3, and in your calculator 8 divided by 3 will be 8 divided by 3 will be 2.6 repeated, so -2.6 or 6 repeating, or you can say even 7, it's fine, meters per second squared. And for the second part of the motion, what you will see is, for the second part of the motion, we will have from 0, that is initial, so -7 minus 0, that is initial, over 2. Over 2.0 equals to -3.5 meters per second squared. So, okay, let's put this information now into the graph. So now for the first part of the motion, that is from 0 to 3 seconds, we have a displacement of, please on the chart tell me, what is it? Positive or negative? So it is positive 12. For the first part of the motion, we have a positive 12, okay? And based on our scale, let's say that positive 12 is somewhere in here. The question will be, how is the object moving at positive 12 for those 3 seconds? Straight up, curve up, or curve down? Curve up. Why curve up? Yeah, curve down, because it is a negative, the velocity is falling down. So you see the velocity falling down means that the curve will be down, okay? The velocity is going up, then yeah, it is slowing down. Then the object will be curved down. Okay, guys? It's following each other. It's following each other, which means that the displacement time graph will be something like this. It's not holding anything. Curve down. It is going up to positive 12, but it is curved down. The way that it's going there is curved down. And for the second one is a -7. So from the position that is there, from the position that is there, the object is going -7 meters. Okay, it's going -7 meters. So from 12 to -7, +12 plus -7 will be +5. This is where the object will end up, at +5. At 5 seconds. And again, the question will be, how is it going there? Is it going straight? Is it going curve up? Or is it going curve down? Question, answers here on the chat, guys. It's curved down. So it will be something like this. And when we are constructing the acceleration time graph, then we have, for the first part is the -0 to 3 seconds is -2.7, let's say. And from 3 to 5 seconds is -3.5. -3.5. Is it clear?